Alright, so this is kind of like what we did yesterday, except for today I'm going to tell you what the mass is of the reactants we want to make. And then you're going to have to find number of moles of the I'm going to tell you the mass of the products you want to make. You're going to have to find number of moles of the products, then find moles of reactants, then find the mass of reactants. So it's 3 steps, mostly what we did yesterday, except for we're going from mass to moles, and then from moles to mass again. So an extra step. All right, let's do a problem here. That's basically all we're going to do. All right, this will be find the mass of aluminum, and this is iron 3 oxide. Needed to make 400 grams of aluminum oxide. Al2O3. All right. So that's the question. Looks relatively easy. And here's the reaction. It's going to be aluminum plus Fe2O3. It's going to produce aluminum oxide and iron metal. Now, as we go along, obviously all this stuff builds off the earlier stuff, so, first thing we got to do is what? Balance it. We got to balance it. Otherwise, we're just going to end up thinking we need the same number of moles of everything. So we'll balance this. That's it. It's done. Okay, next step is we know the mass of the product we want to make. We need to find number of moles. Because we can't go from here over to here unless we're in moles. That's kind of how it works. So we're going to find, let's see, what am I going to do here? Number of moles equals mass divided by molar mass, right? That equation you've seen a million times. And so it's going to be 400 grams is the mass, and then the molar mass of Al2O3. So let's just go ahead and do that. So aluminum is what? What's the mass of aluminum? 27. Okay, and there's 2 of them in here, so it's going to be 2 times 27 plus 3 oxygen. So it's 3 times 16. So add all that together. It's 54 and 48. Is that 102? So it's 400 grams divided by 102 grams. This is grams per mole, but I don't want to mess this up any more than we have to. All right, so 400 divided by 102. What's that come out to? 3 point something? 3.92. And that's moles of aluminum oxide. So that's your N for aluminum oxide. So now we're going to do exactly what we did yesterday. We're going to find number of moles of iron oxide and number of moles of aluminum. So we'll just do each one separately. 3.92 moles Al2O3. Whatever's out here goes in the bottom. Al2O3. And we'll do aluminum first, so that'll go on top. Now we're just writing the mole ratio. 2 is next to aluminum, so 2 moles. And 1, there's nothing next to here, so it's 1. And 1 mole of Al2O3. So it's just going to be 3.92 times 2, basically. And so that's 7.84 moles of, these things go away. It's just moles of aluminum. All right, so we got number of moles of aluminum. We got to do the same thing for iron oxide. So again, 3.92 moles of aluminum oxide. 1 mole. 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 1 m This always goes in the bottom, right? The bottom never changes. And Fe2O3 goes up top. And so this has nothing in front of it, so that's 1 mole. And this has nothing in front of it, so that's also 1 mole. So 1 over 1 is obviously 1. So 3.92 times 1 is 3.92 moles of iron 3 oxide. Moles Fe2O3. Okay, so we found number of moles of both of these. We're almost finished. But we want to know the mass of the 2 reactants, right? Because when we're actually making this reaction, we're going to measure out stuff on a scale. It's going to read on grams, right? We don't have a scale that reads in moles. So we're going to have to find the mass of these 2 things. So that's the last step. So to find mass, I'll do it over here. So we need this equation again, right? Number of moles equals mass divided by molar mass, but we have to solve it for mass. So this goes over here. So we end up with mass equals N times molar mass. Okay? And you've probably seen that a million times. Okay, so we'll do it each separately. We'll do mass of aluminum. Mass of aluminum. Well, that's going to be number of moles of aluminum, 7.84, times the molar mass of aluminum, which we said is 27 grams. And what's that come out to?
It's 211.60.
200 and what?
11.60.
Okay, so let's just call it 212. So that's grams. So this is the mass of aluminum needed, and now we'll do mass of the other stuff, iron oxide. So M Fe2O3. And this is going to be 3.92 moles. Times molar mass of iron oxide. Well, that's, what's iron? What's the mass of iron? It's in the middle of the transition. 56. So 56 times 2. What's that? 112. Plus oxygen is 16 times 3 is 48, right? So 112 plus 48, so that's 160, right? So 3.92 times 160, what's that come out to? 627 grams. What was the question? Okay, so what we did, let's just go over the whole thing for a quick second. We found number of moles of this stuff. Using that, we found number of moles of our 2 reactants. And using those, we found mass of the 2 reactants. So 3 steps are basically 3 long steps. So this is what it is. 212 grams of aluminum plus 627 grams of iron oxide would make 400 grams, what was the question? 400 grams of aluminum oxide. So that's it. Good?
Mm-hmm.
All right, on the worksheet, you only have to do the first one because I have a mistake on the second one, and there's only 2 questions on here to begin with. So just do number 1, and we'll be done.
Yeah,